So this is Quicksort algorithm, which is a lot better than Skylar's because I said so.
No, it's not.
So how it works. So basically what it does, it picks a random element from the array it's trying to sort, and it finds all the elements that are smaller than that element, that pivot it's called. So it finds all the things that are smaller than the pivot, moves them to the beginning. Everything else gets moved to the end, and then it quicksorts the beginning and it quicksorts the end. Basically, that's really all it does. Here's a this GIF doesn't work, so I'm gonna have to go into Wikipedia. But let me start from the beginning. So here it is. So it's picking this element as a pivot, and it's moving everything here. So now it's gonna quicksort this, and it picks that one, and these are all the ones that are smaller, and these are the ones that are bigger, and it just quicksorts that, and it's gonna quicksort that after that. So yeah, now it's quicksorting that. So it picks that pivot, and these are smaller than that pivot, these are larger, then it quicksorts this, and it's going to quicksort that.
Now, what is the big O value for this?
That was there.
Again.
Let me go back again. Wait, yeah, that's over here. So, in the best case scenario, it's big O is n times log of n. It's also the same thing on the average, but in the worst case, it's n squared.
Okay, so it's on the average, it's more efficient than
A little bit more
selection sort.
A little bit more efficient than selection sort. It's kind of okay for big values because log n isn't that big, and n will probably be less than n squared. But why they're different is because it depends on how to choose a pivot. So if you choose a good pivot, then you might have more efficient, like something more efficient, versus if you chose a really bad one, like a really low pivot or a really high pivot. If you pick a really low pivot, then you're going to have a really big, still a really big array to quicksort, and then a really small one. But the same with the big one. So you have to pick something in the middle.
Right.
But of course, picking the middle one will take some time and computations and comparison. So so basically, it depends a lot on how you're going to pick your pivot. So most algorithms just pick a middle value or the middle element, and just kind of hope for the best. So.
Okay.
And then questions. So. Okay, so is a recursive algorithm true or false?
Anyone?
Wait a minute. I don't understand.
False.
Is a recursive?
No.
False.
False.
Down with the K.
It's recursive?
It's true.
Yeah, it is. Of course it is.
You get
And why
It's
would
true.
why would it be true, Scott?
Well, because the quicksort has the same procedure going across just different parts of an array of data.
because a quicksort
It's the same procedure.
because a quicksort's a small because
You
after
could have
it
a
moves
method
them.
called quicksort and just have it, and you just divide it into subarrays and keep doing quicksorting the individual.
Right.
Yeah, so like quicksort, what it does after moving them, it quicksorts the smaller one, and then quicksorts the larger. So it is recursive. You just like keep calling upon it, and then it stops and goes back out.
Right.
Does that make sense? Okay.
Next question.
Why is it better to pick a middle value? I just said that, but
They'll sort more values.
yeah. So you can split the arrays evenly. Better.
Although one does not have any control over the pivot value.
Right, you can't really tell. It's
Right.
kind of have to be lucky.
That's why there's a worst case and a best case.
Yeah, exactly, because it's not a fixed algorithm. There are different variations on how you do it.
These are very, very good questions.
Like perhaps you have a code to choose the median value or some such.
Yeah, but then you
or-
have to take extra time to find the median value. You have to,
Or what about just choosing the middle of the range between the top and the bottom value and the bottom value?
well, then you have to find that value in the array, and that takes.
Well, that's easy. Well, that's very easy.
It takes computation.
What about computation? You
Like,
find
you
the
have
difference
thousands-
between the top value and the bottom value.
No,
and
that's
divide
easy.
them.
That's easy.
That's what I'm talking
But
about.
then pivot has to be an element in the array.
Yeah, you choose the nearest one to that. So
Well, then you have to search through all of them to find it.
that's one loop. Only one loop. Only
Yeah.
one loop makes
Sometimes it might.
No,
All right.
it
Well,
doesn't.
It doesn't, not at all.
so
Okay, now, number 3 is a very, very good question, and it's something similar to what I've seen in previous AP exams. Okay, if you're doing a quicksort, and the current list is what you see there,
25316.
and the computer chooses the pivot value of 3, what would the list look like after the first swap?
21356.
Yeah. I think, is that right? That should be right. Yeah, 21356.
Yeah.
And then number 4. Which
Who
one?
said that? Stephen? Okay,
Yeah,
could you explain to me what's happening there? How did you get to
What's gonna happen is gonna swap the 1 and the 5, right?
Yeah. Because 1 is less than 3 and 5 is 4. So yes, that's right.
Okay.
And it just puts it right next to it every time, so we'll just,
Yeah, just swaps them. Fine.
Okay, very good.
Yeah.
Now, number 4, if the current list is 132576 and the pivot is 5, which lists are then quick sorted?
So you see, it's already moved the ones that are less to this side, so you don't have to.
There wouldn't be really anything until the next value, the next pivot, yeah.
Yeah, it's already sorted. Now it's gonna quick sort some lists.
Well, it's quick sorting, it depends on the pivots, yeah.
The pivot is 5.
No, the pivots afterwards. With each quick sort, you have to have a pivot for each, right?
Yeah, I know. But after you're done with that, you quick sort the lower end.
Using more pivots.
Yes, of course. So it's gonna quick sort 132, and then it's gonna quick sort 76.
Yes.
Right. So does that make sense?
so it would just stay the same after the first swap.
No, there's no swapping anymore because it's
Yeah,
already
there's
done
no
the
swap in
swapping.
the first one.
So then it's gonna have to quick sort the lower and then quick sort the upper.
So first it's gonna do 1, 2, 3, then it's gonna do 6, 7.
Yeah. And then it's gonna mush it together.
Okay, what is the best case
Oh,
big O value for quick sort?
Log of n.
And
And
log
log
n.
n. And log n.
Yeah, and log
Can
of
you speak code?
I didn't write code for it. I did an example if that would help, but
Just go quickly to Google for us, since we're
Oh, yeah.
screencasting, and just
I looked at this code a bit ago. But let me explain what's going on. So, can I use this?
yeah,
software?
absolutely, I
So
encourage you.
then this, whatever. So this part is the important quicksort part. The rest is just some other stuff. Like here is exchange, which like to swap two elements. But so here what it does. So we're quicksorting an array from the low to the high because it's a recursive. So we don't want to make a bunch of arrays. So the low value, like say from the 5th value to the 8th value. So then, so over here, so it tries to find something that's less than the pivot and something that's more than the pivot and swaps them. So that's how it gets all those, the lower values to this side and the higher values to the other side. And then it swaps them, exchanges them, and then once that's all done, because of this while loop, then it quicksorts the lower and it quicksorts the higher. So that's what it is. So I guess like you know it's quicksort because it's recursive, like right here. It calls the same method again, and that's what it does.